喂，好，那我们就开始吧。好，各位同学，大家好，那欢迎回来。Sorry, I should speak English. Welcome, welcome back. I heard that. 喂。Okay, sorry, I should make someone, at least one person in. Where is it? Good. Okay, so let's continue our lecture from last week. Last week was holidays, right? Last Wednesday was a holiday. Hey. Hmm. Hmm. Right, let's continue. So last time we talked about a really kind of complicated problem that with a strut subjected to a force with 40-degree oblique angle and try to push the strut maybe to the ground. And then if we look from that point, if we look from this point, then we can see the cross section like this. And then we can determine the sigma bearing stress between the strut and the pin. So the pin will stop bearing the strut to go out of the monitor, right? The projector to your direction. So the red two square will share this force. So each of the square share half P, and a half P will through that particular area. So you can imagine that the force flow project to on that pin, and then you can have the rectangular area to bearing this force. So bearing stress will be like that. And the second one is tau max in pin. Okay, so why tau max in pin? Because we draw this figure. If we see through from this direction, and then we want to see this pin. Okay, remember this pin is symmetry. So if we cut this equally, we cut that. If we cut here equally, we cut here. Okay, so the reason why I cut here and here, because if we cut both of the here, it may make this one make this picture complicated, and then we want to see this pin, which part will occur the highest stress. So let's cut. So if we cut here and we found that if we cut here and we just see here, okay, we just take care of this and then we ignore that. And then we found that this is half P and it must has the force in this area to make this half P and half P balanced. So this part won't flow away. Okay, although maybe you will say, but it looks like it will rotate. Exactly. Actually, they will rotate, but in the real world, it's still equilibrium, right? So if we want to write it down more correctly, I should draw a moment here. But moment, we will mention this in the next few chapters. So moment is kind of a more advanced skill. Okay, so we are not talking about that later. We will talk about later. Okay, talk about later. Talk about this later. But if we just because now we just need to understand the force, right? Stress and force. So we just need to balance this force at this moment. So you see, this area will have half P. But if we cut this, or we can cut this, right? They are the same. So we cut this, and when we take care of this part and ignore this part, and we found that, oh, this is half P, and this is half P, and they balance. So actually, there's no force, no shear force occurred here. So this green part is minimal. And yeah, this green part minimal. So between this, they are all minimal. 0, 0, 0, 0, 0. No other force added, right? So 0, 0, 0, 0, 0. And then after this half P, wow, this place become maximum, shears maximum. Okay, so as you can see, this maxima occurs here, and the shear force is half P. Okay, this is how we finished last time, right? And then we will continue. This is just a recap, right? So tau mix in pin, okay, equal to half P, and divide by pi d square pin divide by 4 equal to 54000 divided by 2 pi 0.018 divided by 4 and 2, okay, equal to 106.1 m pi. Okay, and we okay, so this is 106.1 megapascal at that green cross section. Okay, and this is maxima in that pin. And the third one, sigma b between the pin and the gusset. Okay, pin and the gusset, and you notice that when the red part stopped the blue part, and then the force will transit to gusset, right? So gusset will stop the pin. So the gusset using this green, pink area to bury the force from the pin. Okay, so 3. Sigma bearing in the pink area, or we can say pin, but between the pin and gusset, half P T G times the pin. This is the area of pink, right? Pink area equal to 54002 divided by 2 and 0.015, 0.018 equal to 100 m per. Good, that's it. Oh, sorry, I should make it right. Right. So this is the third problem. The fourth problem, sorry, fourth problem. Sigma B between the anchor bolt and the base. Right. I will wait a bit. 应该看，在吃饭的时候配的电视是周楚除三害，还蛮好看的，还蛮好看的。对啊，那我就不爆雷了，反正还蛮好看的。哇，周楚除三害的英文是什么啊？A criminal kill 3 bad things. One of them was himself. Okay. Okay, this is a show in Netflix. Quite nice. I recommend you to have a look. Right. Okay. So continue. The fourth one, sigma b between the anchor bolt and the base. What is anchor? Anchor is something looks like that. You know that, right? Like pirate ship. The boat will has this anchor to make the boat stop where you are. Otherwise, boat will flow along the waves, right? So anchor is just in on the on the ground. Okay, won't move. So anchor bolt will be this one, that one, that one. 4 anchor bolts. So sigma b between the anchor bolt and the base. What is base? Base. Okay, here's a base. So as you can see, the gusset will try to move forward and downward, right? Because this is they are sigma theta 40 degree, not sigma theta equal to 40 degree. So if the direction from to the ground is automatically stopped by the earth, we don't need to care about that, right? But the horizontal force, which is p cosine 40 degree, need to be stopped by 4 anchor bolt. So you can imagine that 4 anchor bolt has 4 rectangular projection area to stop that p cosine 40 degree, which is the light blue. Okay, light blue. So light blue, which has 4 light blue. Okay, so sigma barrier stress on that 4 area is p cosine 40 degree, and we have 4, right? So share this p cosine 40 degree, and then the shape, the area will be TB times D bolt. Okay, D bolt. So equal to 54000 cosine 40 degree divided by 4 and 0 0.008, 0 0.012, and 107.7 megapascal. Okay, so that's it. Final one. Final one. The fifth one. The fifth one said we are going to determine tau in anchor bolt. Tau in anchor bolt. Okay, so you can imagine that the force has p cosine 40 degree from to that direction, right? And then it will the force will flow parallel to certain area through the anchor bolts, right? So the anchor bolt has 4 yellow area. This 4 yellow area will share that force, right? So each of the anchor bolt has p cosine 40 degree divided by 4. Okay, and it directly tell you tau bolt p cosine 40 degree divided by 4 divided by the area if flow, but the area is parallel to the p cosine 40 degree. Okay, so this is the circle shape. Too big. 5400 cosine 40 degree divided by 4. By 0.012 divided by 4. And equal to 1.4 megapascal. Okay, that's it. So the shear stress will look like that. So maybe you will figure out why we need to calculate all these values, because we need to look at those value won't exceed the material compatibility. So maybe some material cannot afford such big shear stress, or they may not cannot handle such big bearing stress. So we need to see if they will be broken or not. Okay, so this is quite good knowledge for you. Later, you will, after this course, you may know how to examine what kind of material will break under certain force. Okay, so this is how the reason why we need to study this subject, this course. Okay, any questions? Okay, I believe I don't need to translate because the color things tell you everything. Color tell you everything, right? Color. About color, I remember there's one thing happened during my PhD when I was a PhD student. One day, I need to make a report to my supervisor's supervisor. Used to be. Okay, my supervisor was is a professor, of course, and his supervisor when he was a PhD student still in the same department. So my supervisor asked me to write down some report, or sorry, it's not write down, just prepare the slides, talking slides, PowerPoint, to explain what I'm doing to his teacher. Okay, so okay, I just try my best to do all the slides and colorful, very beautiful. And then before the presentation, I present to my supervisor. And my supervisor, after my rehearsal, my supervisor told me, your slides is good and your presentation is good. However, I forgot to tell you, my teacher is colorblind. So, wow, really? So I try to make everything non-color. Okay. Oh, by the way, my supervisor's teacher is a genius, really genius. Uh, so I found that maybe this is fair. If God take you something, and then your other thing will become better. I don't know, but he is a really talented and smart, intelligent teacher. And although he's colorblind, I didn't know that, because the thing I just noticed that he always wears the same clothes. He never changed his clothes. I believe, but he's not good. Okay, but really, but I believe he just buy every clothes like 7 or 14 pairs, the same pair, and then wear every day with different, but the same color, the same thing. So yeah, so and I noticed that if you trying to write down this thesis or paper or academic writing when you are going to pursue your master degree. Okay, when after that, when I do this academic writing, when I prepare the figures, I will try my best to use non-color information For example, like this one or that one. I won't use that one and that one. Okay, so that's the reason why. I mean, but now I'm teaching the course. I'm sorry. So it will be really difficult if I just using 1 and 2 star or something like that. This is really difficult. I'm sorry. So if you're colorblind, it's okay. You're really smart, and then you can let me know, and I will explain to you in privately. Okay? Yeah. Next one. So the following two questions is way more simpler, easier than what we just finished. There's a punch, okay? Punch, trying to penetrating the blue plate. And then you can imagine that the punch, this one, the punch, will penetrating this blue plate, and then you can say, oh, tau average in the plate. So your force will penetrating the blue plate and then cut through it as a hole, right? So you can form a hole on the blue plates, and after it form the hole, what is the tau average in the plate? So again, tau is the area, is the force flow to the and flow to the object you are going to examine, and also the area you divide is parallel to the force, right? So the parallel to the force area should be this, right? This area, parallel to the force, okay? So it's easier. So 1 tau average equal to P divided by pi dt equal to 11000 divided by 0.008 pi times 0.02 to a 1 and pi. Okay, that's it. And the second problem is sigma c in the punch. Oh, sigma. Sigma c here is actually compression. Well, I'm sorry that the C here is too small, and then I should write it down as a whole words. Okay. So the compression, so actually is the uh just we were just taught in our beginning of the course, right? Beginning of this semester. So sigma equal to P divided by A, 11000 divided by 0.0220 square 4. 350 m per. Okay, that's it. Easy. And we can say the first is the first problem is focusing on the blue plate, and the second part is focusing on the punch, or you can call it cylinder. The next one is also easy. Next problem is easy as well. Okay, this is relatively easy. I'm not worried about this. And next problem is also easy, but I will, sorry. Ah, yeah, you are right. You can add in negative if you are going to say this. Yeah, sure. You're right. Thank you. But I don't know which one should. I think maybe P. Yeah, you are right. So maybe this one should be full. Should be better, right? Good. Thank you. Can you tell me your number? 111. Triple one. Good. 613. Oh, 27. Cool. Okay, that's great. That's great. You know, recently I'm dealing with international money transfer because I went to US for 8 months for the research cooperation something in 2022. Okay. And then I have some bank account in US. And then after that, I want my money transferred from US to Taiwan. So I need to call because I changed the number, right? I changed back to my Taiwanese number. So if they and now if you want to do the transfer money, they will call you or send you some kind of identification code. So I cannot receive that code. So I need to call saying that, oh, I changed the mobile phone and blah 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 blah. And then after those conversation by phone, this is really difficult things, even for me. Okay, so this is really difficult. And then sometimes they will say, okay, this here is your identification code 1116130227, and you need to and then bye, and then you need to do prepare these things. So I think the most difficulty or something I learned a lot during my study abroad is that I know how to dealing with those English listening or dealing with bank account in English. So after you can dealing with that, when you come back to Taiwan and you say, "Oh, I can do everything because everything is in Chinese. I can handle that easily. Even I can handle that even in English." So it will make you more confident about everything in Taiwan. So it's just really interesting. So sorry, 中间的长方形为什么不是中间的这一根呢？对对对对，第一层 T 接二层 Oh, so if you using D and T, D times T, it will looks like this. Okay. You imagine that this force acting like this line? Maybe not, because the P here will be uniformly distributed in this area, right? Remember, because this P is kind of far away from this, although this is the point load, but it will, you know, become a uniform. So everything has force. It's kind of a circle, right? So the force, the force will uniformly like this, and then it will touch the area surrounded. So it will You cannot just using this one. Okay. Yeah. Thank you. Good questions. Good. Nice to have the questions. Any questions from audience? Okay. Good, good, good. Very nice, very nice. Next one. Next one is even more easier, but I will introduce one simple concept, very important in mechanics of material, because this problem is too easy. Okay. So the problem itself is not important. Okay, let's take a look. So there's a thickness H in dimension A times B, and shear force is V. Okay, so the shear force V act parallel to the surface, blue surface, and then make the gray part, gray stuff, well, gray material is what we are focusing on. Okay, so they said average shear stress tau average, easy, right? You see, the tau, sorry, tau average, your tau average is V divided by the area it parallel to the area to the force, A B. Okay, and that's it. This is the first one. The second one is that horizontal displacement. Okay, so horizontal displacement looks like this. If you have the force from left to right, so this gray stuff will become a parallel pipe, 平行六面体. Okay, and then you will notice that it will has a displacement in the horizontal part. So we want to calculate the second one, horizontal displacement D, this one. Okay, this one. What will it be? And you notice that there's a gamma here. The gamma is a radian, is an angle between this line and that line. Okay, so you can imagine that the D equal to H is the height, right? And tangent gamma. Okay, tangent gamma, you can get the D, no problem, right? Right, so now you can imagine that, of course, typically, if you have a force from left to right, and then this displacement typically very, very small, right? Infinitesimally small. So this is answer. But if we assume shear, and then later, okay, shear modulus. If we assume shear modulus is G, and our gamma can be tau average divided by G, right? And then actually this is all not important. The most important thing is coming now. So now D equal to H times tangent V A B G. Right, now this is really important now. If the gamma is small, when gamma is small, which means shear strength is small, the tangent will approximately equal to its well, naturally you can ignore the tangent. We're just using the radian inside. Okay, so basically the real real important concept here I want to give to you is that tangent theta will equal, remember this is radian, okay? And sine theta will approximately to theta if theta is small, okay? So this problem is very simple, right? So easy, very easy. So too easy to be true, right? But the main problem, then main concept I want to give to you in this problem is that if you have theta very small, which is shear strength, which will be always the case in this course, because we are all talk about small deformation, small infinitesimal displacement. Okay, so when you talk about shear stress, shear strain, the shear strain is angle, right? It's angle. The angle is really small, and then you can use that concept. Okay, so all we need to know this is that when the gamma is small, tangent can be neglect, sine can be neglect. Okay, let me rewrite it. Otherwise, you may think this is gamma. V. Okay, that's it. Easy. Right. Um, any questions? Okay, good. We almost finished the first chapter. We have 2 more problems left. Next one, we are going to introduce another concept. Okay, another concept. The next concept is related to related to breaking. Okay, breaking or fraction. Next topic will be related to fraction. Right, the fracture we need to talk about allowable stresses. Allowable means that you can only suffer that value of stress. If you exceed that stress, it will break. Okay, it's not allowed to exceed allowable stresses for the materials. Okay, so typically in the when you buy a material from the company, okay, they actually will tell you, okay, this product has the allowable stress something, okay, some values, but typically they will give you some tolerance or factor of safety, okay, to preventing you really make it, you really try to push their limit. Okay, for example, your elevator. Elevator said only for 10 person. Do you think if you have 11 people get in and it will break and damage, will be that like it will be that case? No, right? Because they have safety factor. They will they will kind of times a factor to make it safer. Okay, to to prevent human do stupid thing. Okay, so the factor called N, and this is requirement of the product, and this is it really break. It really breaks actual strength and require the strength. Okay, so in general, this will be greater than that, right? So it's general, it should be 1. More than 1, greater than 1, or 2, or 3. Can you be 100? Yes, but it will be really expensive. Okay, it can be 10. Okay, well, it's really expensive. So if you are a designer and you have a boss, and your boss will try to make it more, it's cheaper but safe. So you need to make it like 1.2 or 1.3. It will be better. Okay, that's it. So this is safety factor. Okay, this is just a concept for you. Okay, for your future. Okay, when you enter in an enterprise or company, maybe factor of safety will be the issue for you. But now in our tests or exam, it's okay. We just calculate it. Right. Next one, we will talk about allowable stresses. Allowable stresses. Oh, I should replot this, otherwise it will. Don't worry, you know this before, so sorry, no. The reason why there's no lines here is because uh I don't want to how to say that, if I just give the lines here, it will read too similar to the figures in the textbook. Okay, so I need to make it that. Okay, so allowable stresses. So typically for the like material metal, like ductile material, it's easy. Just sigma y, okay, tau y. So sigma y and tau y divided by n1. The n here will be the safety factor, right? So the sigma allowed will be the requirement of the product. You see here. So you can imagine that this one go here and n goes down knee, so you can get this. So sigma y is the material actually break or actually yield, right? Not functional. So sigma y divided by n1 will be sigma allowable, which means that in your product brand box, your box of the product, it will write down, okay, it's sigma allowable will equal to something, some value. And the some value must be related to sigma y, okay? And with the some factor on it. Right, that's it. So sigma allowed looks like this, and tau y has their own tau allowable, okay? And ductile material. Oh, they use ultimate stress. They use this one. Okay, brittle material mean using ultimate. Okay, so basically we are not talking about brittle material in the in this course. We typically talk about ductile material, but just one concept. Sigma allow, tau allow is the value that the stress value cannot exceed that value. Okay, if it exceeds that value, thing will broken. Okay, so if you have an allowable sigma tau sigma bearing allow, okay, if you have this on your material box and you want to actually design your system, your things, trying to assemble them become a system, you need to know the force. So if you need to know the force, you need to times their area of the cross section, right? So if you time their area of cross section, you will get the allowable force, allowable shear force, allowable bearing force. Okay, easy. Now let's take a look. So there is a hanger on the ceiling. Okay, on the ceiling. And this is a side view. They have it has a P downward, and you can have so this one is the side view, and the other view is this one. You have two bolts to fix bolt 1 and bolt 2, fix on the ceiling. Okay, fix at the ceiling. Okay, and bolt 3 looks like this, and oh, it's called washer. Oh, this one is called washer. Okay, this one's called washer, and the blue part is the hanger. Okay, the hanger has the force, try to push it down. Okay, and the B1T, B2D, the size, and they want us to define what is the allowable tensile loading of P. So they want us to determine the P value if sigma allow in main part of the hanger is 110 MPa. Okay, the main part of the hanger. What is main part? This one. Main part. This is not main part. This is main part. Main part is this one. Then this one is kind of, try to fix on that on the ceiling. But the main part of it, their sigma allow is 110. So we want to see how large of the P here will exceed the sigma allow 110 MPa at this. Otherwise, it will broken. Okay, so next hour, I will try to let you know this one. See you later. If you have any questions, just let me know. 好，其实是一样的，是一样的。
所以因为是因为他们面积一样，所以一样，还是不管是对于哪边的意思是一样？
哪边意思都一样。对，
因为我以为这个力是在这个平面。
不是，它是整颗往前走。
嗯。
因为这个东西是有两个gusset，然后 gusset 是这样子，像一个拱，墙在上面这样，对不对？然后那个拱要被往前推，所以那整面都是往前推，整颗往前推。对对对，所以其实黄色每一个黄色这样一直往下都是一样，不会。 刚不是说我看了《周楚除三害》吗？然后啊，有一个东西我就觉得还蛮有趣，可以讨论一下的。哦，其实最近我有一两件事情想跟大家讨论一下。像周主任上一队有一个蛮，这样会不算暴雷啊？好，算了，再说好，那就不要讲，以后再说。那好，原本有个小讨论，就是大家觉得那位勒勒高中老师的代课老师的脖子的那位，就是大家有什么想法？或者是好了，如果今天我在这里，然后有一个同学这样，那大家觉得我该怎么做？我想要询问大家的意见，我该怎么做？就是对，就是当下他就开始这样啦，然后我就开始，好，那你觉得我该怎么做？对，好是啦，但我还能混吗？我该怎么做？跑，对不对？你觉得是要跑？我们不能逞一时之快啊。我觉得我可能会很想打人，但是我知道我不行。但对，那我该怎么做？我要是不理他，我说好，我继续上课，然后开始继续上，他就在那边骂我，就继续上课，还是什么？就是大家可以给我一点意见吗？我还真的不知道我该怎么做啊。 没有啊，他不出去啊，他就这样子啊，那怎么办？所以我该怎么做？因为我也自己是老师啊，我那时候看一下，我想说，我可能没办法处理的比他好，对啊，怎么办？还是我就说停课，大家自习，然后跑掉了，可能这是一个很好的做法。对，因为少上一门课其实不是很重要，生命危险才是最重要的，生命安全才是最重要的。所以大家觉得怎么样啊？所以同学你就可以直接说踢他一脚，你还是开玩笑的吧？如果你真的看到我，你如果真的看到我就这样开始踢他一脚，然后还被录下来，我可能我可能不用混了吧？对，所以应该是开玩笑吧？所以我可以做到什么样的程度的仿生啊？不行吧？哎，我们来点实质的好吧？你不要害我。对，我已经被勒住了的话，如果当初我被勒住了，那那你们会来救我吗？会哈啊，好好好，那哎，那如果今天我被勒住了，然后我拿一个东西砸他头，可以哈？你觉得我是不会怎么样，对不对？哎呀，这个不用我很厉害的律师也可以过吧？解释问哦哦，好像有道理哦。因为的确是真的被拍下来了，搞不好，但是我可能就是受怕，我会觉得我怎么知道下一步他会不会更怎样，所以我就先这样，好好好好好，OK，对我就其实也蛮就我看到网络上的论战，有人说学生其实是值得被关照啊，然后就是他这样是合情合理的，但是也有人说不能这样子，然后也有人说老师太呛，然后也有人老师说他处理的很好，我想说哇，这个真的太两极了吧，我真的是完全不知道风向在哪欸，然后我想说，如果今天是我的话，我该怎么做？然后我今天早上看了，然后我就想说，我到底要怎么做？然后我觉得我应该就会是直接就停课，我就离开，我应该会是这样的，我应该是停课，再见，我走，应该会这样。但是啊，有的时候人也是无法控制自己的情绪的。就如果今天他弄我弄到一种程度，我可能失去理智了，那我也不知道我会怎么做。嗯，希望。然后啊，这时候我就非常的佩服国小、国中、高中的老师。真的，我非常非常佩服他们。要我去当这样子的老师，我会不想，因为毕竟各位，你看，大家都是我讲不好听一点，或者好听一点，大家都是天选之人，大家都是真的是天选之人，就是都是非常优秀的才会来到这里。所以我觉得，哈哈，我就不用去面对，我就不用去面对，就是说可能会出现，啊，应该说几率就会变得非常非常小，对啊，那所以我觉得这是很感恩的一件事情，就是我10年来，我没有，我有没有怕过吗？我应该是没有怕过了，我应该是没有怕过，我只有怕同事，老师，我只有怕老师，我没有怕学生这样，对。好，所以就是这是我很感激，就是觉得他们真的很了不起的一个那个，所以好没事，那大家要救我，知道吗？如果遇到问题的时候，Okay, I just talk about the recent news about the students who may have some mental issue and then who attacked his teacher, and I'm wondering how should I do? Okay. Right, continue. So this one, main part is that one. And so each item, each problem in this in this example, talk about certain part of this material, and each part has its own fracture or breaking criteria. So we want to calculate each of them and try to find the force that make this thing won't break. Okay, so that's the purpose of this problem. So now let's examine that each by each, one by one. Okay, first one, main part of the hanger, the sigma allowable is 110. So 110, so P1 equal to sigma allowable times the corresponding area allow times, okay, B1 T, B1 T, okay, so your force down, and this is kind of sigma equal to P3 divided by A, okay, so B1 T and 110, 0.03 A, 113, 54.3 kN. Okay, so again, I would like to say if the force is 14.3 kN, this part will almost break. If you give it 54.9 kN, and this part will break. Okay, so if it's greater than this part will break. Next one. Sigma allow equal to 75 MPa. Hanger beside by both 3 hole. Okay, so what is hanger beside the both 3 hole? Both 3 is this one. Both 3 holes this one, and the hanger part, blue part, beside the blue, the green. Sorry, the hole. So these two part, right? These two part. So I will using 2. Okay, so sigma, so P2 sigma allow times A. So sigma allow times B2 divided by D times T. Okay, so you can imagine that B2 divide by D. So this is two lines here, and times the thickness T. So you can obtain these two area. So this area will share the P2. So P2 is here, P will be here. So this is P1, this is P2. 1 and 2 are candidate of the P 候选人啦。好，P2. So P2, we want to calculate the P2, which is just break this part. Okay, so P2 equal to 75 MPa times 0.075 minus 0.025 times 0.013 equal to 48.8 kN. Okay, so if the P here equal to 48.8 kN, this part will almost break. If you exceed that, if you have 50 kN, oh, this part will break. So how about 54.3 kN? Of course, this place is break, right? So this part is weaker than this part. You can see this from the value. Right. Third one. Third one is sigma bearing allow is 180 MPa between the hanger and the bolt 3. So you see hanger, and the bolt 3. So your bolt 3 is trying to go down, but the bolt 3 stop it, right? So the bolt 3 stop it. The bolt is the darker blue, right? Dark blue, and penetrating this hole, and this blue part will going down. So the both three bear that force. So the force going down, and the force will be project and bared by this area, pink area. Okay, so again, P3 sigma B A equal to sigma B times B T D T D T. Okay, D is the diameter, T is the thickness. Okay, so 180 MPa times 0.025, 0.013 equal to 8.5 kN. Okay, so looks like this bolt is quite strong, stronger than this one and that one, stronger than this part and that part, because you need to exceed 8.5 kN, and this bolt will break. But before that, these two things are break, right? Finally, tau allow 45 megapascal in the bolt 3. So bolt 3, the force is going down as well. Sorry, the force is going down still, but now you are not calculating the bearing stress. You are calculating tau shear stress. The shear stress is you need to find the correct area. The area would need to be parallel to the force. Excuse me. So this is blue cross section. Ooh, sorry. 不会跟陈桂林一样吧？我还真的有上网去查，肺癌是不是真的会吐黑水？真的，真的会吐黑水。嗯，这样算暴雷吗？Anyway，而且很好笑哦，我在查肺癌的第一个搜寻就是会吐黑水吗？真的，真的，真的，我没有骗你，根本不用打完，你自己去查。好，来，这边P4 这边sorry，P4 is for the shear stress across the bolt, right? You can imagine that the force, we're trying to do this, right? But you will notice that this side view of the system. Maybe I need to make it. Okay, so this is force P, but because we are going to see this region, right? The green part, right? But because they are two washer, okay? So you can imagine that actually this P has two things to support. So this should be 2P, 2P. So each green part has half P. Okay, so this is a little bit dangerous. If there is only one, this one, and there's no this one, there's no this part. And then of course this one will be P and P. But now because you have two washer, so you have half P, half P. Okay. So the only reason we divide by two is because they have two washer. If they only one, it will be P. Okay, so this is just, you need to be careful about this. Right. So you should have two times tau allow a. Why two? Because these two should be go here, because it's a half P4. If this is P4, if you go to here, it will be P4 divided by 2. So this is P4 divided by 2. Okay, so the 2 is come from here. All right. P4 is the candidate of this one. But when we talk about the green part, each of them only have half P. So here, P4 need to be times 2. P4 equal to 2 times tau allow A. So this should be, you need to be careful about the differences. Times pi d squared. So sometimes students will ask me why I need to learn material science, the mechanics of materials. Yeah, actually, I cannot provide you a good answer, the reason to study this subject. But don't you think this is difficult? I think this is really difficult. But when you feel, when you overcome this, and it will train your mind to become more smarter. Okay, just like what I'm talking about when I'm dealing with stuff in US or UK in English, and then I come back to Taiwan, I feel easy because everything is communicated in Chinese. So it made me feel more confident, right? So here, this is a really difficult task. And then if you overcome this, you can obtain really good grades, which prove that you have the ability to solve this difficult problem. And you will feel confident as well. So maybe that's it. 44.2 km. So now, bonus time. Can you tell me, in case this material system won't break, which one should I choose? The force. Should I choose the force or the P? No break. Which one? Okay. P4. Yes, exactly. Easy, right? Ta-da! Okay, so what's your number? 111 613 005. Good. Good. So actually, there are more problems items in the textbook, They also considering this one and that one. Okay, so please continue. So after you calculate everything, maybe the answer is not this one. Okay, so please continue. Please continue. Continue. New. Well, in textbook 乱翻的训爆了我啊，就这样了啊。Please continue in textbook. Okay, right. 嗯，2年前我不知道哪根筋不对，我去学拳击。对，2年前了，现在没有了。我想说，来试试看吧。然后就去学，累死了，累死了，真的累死了。热身什么？跳绳，光跳完我就累了。而且一开始跳的时候就是这样，2、3次就这样。但是到最后就可以跳个几百下，这样子那没有问题。然后非常非常累，因为你知道拳击它要去守你的脸嘛，对不对？还有你的腹，所以其实它是一个很奇怪的动作，是要这样子，这样，呃，然后你要看得到对方嘛，你要看到对方嘛，然后还有什么？反正各种不同流派哈，好像要头要是这样子，因为如果你是这样子的话，你被打的话，这边就完蛋了。但如果你是这样子的话，这边被护住了，所以就还好这样。反正还有很多事情没嘎嘎，然后光是这样子，你想想看哦，这样子不要动，你可以撑几分钟？手知道你要不要试试看？现在超累，超累。你会不会觉得人生时间过好快哦？怎么你就站上拳击场上你就知道了，哇，1分钟这真的是有生以来最久的1分钟啊！怎么还没有完呢？对，真的很可怕，很有趣哦，很有趣。好了，以后再跟大家分享这件事情。I just talk about the experience when I try to learn boxing, and it was really exhausting. Okay, especially for the skipping rope and the guarding position. Just maintaining the guarding position and will make you exhausted. Right, next. 那我越来越会翻译了。Okay, design for actual loads and direction. So basically, what we currently doing is trying to we know the sigma. We know we know the sigma. We know the sigma and we know the area, something like this. So area are all given, right? Geometry are all given, and sigma allowable are given. So in the previous page, we calculate the probable allowable force. However, typically in the daily life, we won't do this. We know how we have the requirement demanding of the force. For example, we know this light, how heavy of this light, right? So we need to, and we buy a material that the sigma is fixed. So all we need to do is trying to determine how large of the area. So actually area is what we're going to learn, design in our daily life. Okay, typically P, we know that is known. Is the only unknown is area. Okay, the geometry design. So this is actually the real daily life problem. Okay, so let's take a look. And also this problem is really important because I'm going to give you a one very important concept, force balancing. Okay, force balancing. Let's go. So now if we have a banner, okay, banner here, and then this is a wall, and then you pin it on it. Okay, you pin on it. There's a pin and pin, and you have two bar. Okay, and then you have two hanger to hang the banner. Okay, so sigma allow in tension is 125 megapascal. The material, the blue material, and tau allow is 435 megapascal. So we know that these something we bought from material shop. Okay, it tell me sigma allow is 125. The shear stress allowable is 45 megapascal. Okay, and then we want to design the area of AB, the cross section area of AB, and the diameter of the pin C. Pin C. Okay, well, they are all blue lah. Blue. They are blue. Let me draw blue. They are all the same material. Okay, right. So let's design. So we take a look. The W is 5.4 kN, 5.4 kN, which means that each point is 2.7 kN. No problem, right? No problem. And then we are going to do something. Actually, this one and that one is wait a moment. Sorry. Right. Let me take a look. Sorry. Okay, we'll start from here. And then we are going to do the force balance. You see, these two, these two things are fixed, pin on the wall. So they will have reaction force. So imagine that reaction force. A, you will have RAV, RAH, but we will have a slash on it, saying that this is a reaction force. RCV, RCH. Okay, you can mention that this pin is something like pin. Okay, so you can rotate, but you cannot go right or go up, go down, cannot go left and right. So you can X and Y are locked. Okay, so which means that they will have horizontal and vertical force, reaction force. Okay, to make it stay there, to make it stay there. But the reaction force value, we don't know that. We need to calculate that based on your load, actual load, 2.7 kN, 2.7 kN. And then again, and also, we don't know the actual direction of this reaction force. So this is the first concept. We just assume that positive. Okay, up are positive, right hand side are positive. So in the beginning, we assume the reaction force. We just assume that positive. So you see, even C go up, go right. That's it. And then we are going to calculate the value. Okay, so in the entire system, these 6 force need to be balanced and momentum balanced, right? So let's begin. I believe you're a senior high school student. When you were a senior high school students, you done the moment balancing, right? Sigma MC equal to 0. And then we also need to give you a concept that we set clockwise negative and counter clockwise positive. Okay, this is really important. Okay, we set that, and we set the C point as a origin. Okay, origin. So the good thing is that when you set the origin, when you calculate the momentum balance, these two unknown will go to will passing through the origin. So they will have 0 arm of the force. So they will cancel. They will be neglected. So always choose the most unknown point as the origin. Okay. So now, if we set C as a origin, and then let's take a look. Minus R A H I H times 2. Why minus RH times 2? You see, RAH clockwise, right? It rotate clockwise about the point C, right? So this is minus, okay? And 2 is arm, forcing arm, right? And then 2.7 times 2.6. Which one? 2.7. The 2.7 times 2.6 clockwise, minus again, right? Minus. And then minus 2.7 times 0.8. Again, minus, right? Minus. Okay. And anything else? Anything else? No, because this one, sorry. This one, that one, and that one, they are all through the origin. So they don't have any forcing on, right? So that's it, equal to 0. And you will successfully get RAH equal to minus 4.5659 kN. Oh, you notice that. Hey, this is minus sign. Minus sign means it means your assumption about that force was wrong. Okay, so the direction you assume it is positive, but it's wrong. It's wrong. So basically, your RAH should be that direction. Should be that direction. Okay, RAH. So the concept of this this really important thing is that when you write down your unknown, you need to systematically do it. Okay, you need to do it systematically. You need to assume that they are all positive, and then do the force balancing, momentum balancing, and then you find that, oh, this is negative, which means that the direction you assume obtain a negative sign, which means that actually they are in another direction. Okay, so this is assumption. This is the final result. Okay, so sometimes when you see the textbook and you find that every time their figures just has correct direction, you say, why I should know that? When I was young, when I was your age, I think, why you know that? Because your answer, you know that, but I don't know. But actually you can know by the calculation. Okay, then we can continue to solve the rest of the unknown. We're using y direction force balance, RCH plus RAH. Well, I still using this plot, okay? I still using this plot. I'm not using this. I'm using this. Or you can say this is minus RAH. But that means the same thing, okay? Equal to 0. And then RCH equal to 4.59 kN. Okay, so 4.59 kN, which means that RCH is correct direction. So RCH. Okay, correct. Right, and then next one is also a really important things. Right. Next one. Actually, we found that it's a little bit difficult for us to proceed to calculate the remaining unknowns. How can we do? Because this is a system, right? There's a system. Uh, we do the equilibrium for the system, and then we cannot continue. We don't have any more equation. How can we do that? We can use another concept called every part of the, the system itself is in equilibrium too, right? So this system equilibrium, yes. This part only, yes, equilibrium. This one, equilibrium as well, okay? So we can cut that. We can cut that and examine this part and do the balance, force balance, momentum balance for this part. And then we can obtain more unknowns. Okay. So now if we cut this and we examine that one, and we will know that RCV, RCH, 2 kN, 2 kN. Okay. And the most important thing is that if you cut it, okay, if you cut it, you must have some force to your AB member, AB bar must have some force act on the point B, right? But we don't know how large of it. We don't know yet, but we are sure it is along this direction. Why? This is called actual loaded member. actual actual loaded member. The resultant force is always along the actual direction. What does that mean? It sounds like a useless sentence. 像个废话一样. But let me show you. Okay, so actual loaded number. This one is an actual loaded number. This one and that one. Sorry, this one is actual loaded number, but this one is not actually loaded number. What does that mean? This is actual member, but load is not actually. But this one is actual loaded number because the only point here, only load is these 2 points, right? So no matter how you stretch it, the load always follows through this actual direction. Okay, understand what I mean? But if this load is like that, no, this is not actual loaded number, but it's an actual member, but this is not actual loaded member. Okay, this is actual loading member. Okay, the load is just flow through the actual direction. So imagine that the load is always flowing through this direction. If you take out this AB, this point will see a direction like that. The force will follow the direction of AB, but we don't know the value, so we should write down FAB. OK，这边中文要讲一下哈，就是轴向受力杆件。我刚刚讲，这就是轴向受力杆件。如果今天是你的力都只在两边的话，你看它就是会这样啊。哦，你不管怎么拉，我随便拉，我左边随便拉，右边随便拉，它就是会动来动去嘛。它的方向力都是传达在它的轴向上，但是下面这个就不是了，下面这个它是这样子，然后有两个这边拉这边嘛，那当然就不是轴向啊，因为它的力就是从这边出现，从这边出现，它就不会流过去了。所以说这样子的不是轴向负载的杆件啊，但这个这样子的话，就是轴向负载杆件。那只要是轴向负载杆件，它的受力的合力永远都会沿着它的轴线方向。所以我们今天把 AB 拿掉的话，还是会有这个力出现，但我不知道它多少，反正就先把它设定在上面。反正等一下做力平衡的时候，这个 FAB 可能就会出来，其实不必啦哈，因为接下来我就 So we can continue if we just do the sigma MB equal to 0. So MB equal to 0. So we just draw it, but we don't use it. Okay. Oh, I found that English really take more time. RCV times 3. Why negative? RCV is here, right? And it rotate about the B is clockwise, so it's negative. Times 3, of course, 3 is the length, 0.8 plus 0.4 plus 1.8. And plus 2.7, 2.2. Why? Because 0.4 plus 1.8, 2.2. And this one about rotate about the B is counterclockwise. So it's plus. Okay. And another, this one, 2.7, 0.4 forcing on and rotate about B counterclockwise. So again, another plus 2.7 minus 0.4 equal to 0. And RCH flow through the with 0 forcing on. Okay, so RCV equal to 2.34 kN. Okay, our assumption is correct. Sorry. So RCV is correct. Right. Then we're almost there. We're almost finishing. Oh, you're not bad. We're almost finishing the balance. Sigma Fy equal to 0. And RAV plus RCV minus 2.7 minus 2.7 equal to 0. RAV equal to 3.06 kN. So RAV are also assumed correctly. RAV. Okay, that's it. So all the value are done. And then tomorrow, I will using this RAV, RCH, RCV, blah, blah, blah. We will calculate FAB, force through this AB. And also because we are going to calculate the area of the AB. Okay, so yeah, that's it. See you tomorrow. If you have any questions, just let me know. Thank you.
什么东西？就是我刚刚把它点打好，然后阿斯奈也做了，对不对？那等一下，它是正的，但是的，它是正的，就是老实说，按照论述的意义来思考，其实正的不意外。
好，为什么？
然后我可以画给你看嘛。
我没有时间，我要走了。
简单讲说，就是因为enthalpy 一定是负的。
OK，
然后 enthalpy 除以 T 平方一定也是负的。
OK，
然后所以积分积起来一定是负的。
OK，
然后积分积起来是负的，然后再加一个负，它就变正的。
OK，
然后它每次都迭代一个抱歉我它每次都等于说这个值负的橘色框框一定是正的。
OK，
然后这个值是0。然后所以每次加上去一定都是正的，一直加上去都正的。所以这个 G 怎么样都是正的。
OK，
然后它就长这样。
好，
然后我一开始是想说，是不是因为我应该把那个，就是因为它
先等一下好了，
因为它是线下面积，所以我是不是应该把它的那个线下面积的部分删掉，然后就是强制把那个负的橘色框框改成负号，然后